Okay, well, hopefully this isn't too loud. The sound is my computer because my mic's next to my computer. Hopefully you can hear me. I'll hear it. I'll mix this in a second. I'll turn this a little bit down. Yeah. All right. Well, hopefully this works. All right. Unit circle. Hooray! Is actually so easy. So the first thing is this. So every angle. Well, there's many angles in between these, but all the where the hell did my cursor go? All the important angles are going to be divided by 6, divided by 3, divided by 4, and then if they're on an x or y axis, they're either divided by 2 or just not divided by anything. So like that's pi over 2. Divided by 6, and this is another thing. Okay, you like divide by 6, it's a 60-degree angle. No. If it's divided by 6, it's a 30-degree angle. Divided by 3, it's a 60. Divided by 4, it's a 45. Or it's based on a 45. That's your reference. So what that means is that no matter where you are, it could be like you could get 24 pi over 4. Okay? 24 pi. But automatically, you already know it's divided by 4. So it's going to follow a certain rule. Because anywhere you go in the unit circle, any 45 has the same coordinates, just different signs. Is it so like 45's here, positive positive, negative positive, negative negative, positive negative. So you just know, bam, like you get in the mindset. You know it's 45 degree. You know what you're kind of dealing with. Now, say you wanted to find the actual degree to that. That's really easy. Say you're converting radians to degrees. You just pi becomes 180, so 24 times 180 divided by 4. Bam, that's your actual degree. But you don't ever need to do that. You only ever really use radians. Anyways, back to this. So, sorry, I didn't even get ahead of myself. I don't teach much, but it's whatever. Yeah, so you got your main. Why is my cursor? I can't see my cursor. Your main denominators. And these are all. That's the base. Once you get that down, it's easy because then all you gotta do is memorize the coefficient of pi, because it's gonna be the same. It's gonna be divided by 6, divided by 4, divided by 3, and then divided by 3, divided by 4, divided by 6, divided by 6, divided by 4, divided by 3, and so on. It's gonna keep repeating. Then, once you get that down, all you gotta do is memorize the coefficients. So, for the first quadrant of the unit circle, it's all 1. So it's just pi over whatever, pi over whatever. So, oh boy, it's gonna be rough because I'm doing cursor. Pi over 6 because it's a 30-degree angle. Pi over 4. Pi over 3. And then this is going to be, so it goes 1, 1, 1, 2, 3, 5. So 2 pi over 3, 3 pi over 4, and then 5 pi over 6. And now Miss Burns will refer to it as like 2/3 pi, 3/4 pi. Doesn't change anything. It just, she puts it like pi times 2/3. I have 2 pi divided by 3. It doesn't matter. Honestly, her way is probably better. I learned it my way. So, oh, also, this is gonna be, where are we? Where's my cursor at? Oh. This is gonna be pi. It's 180 degrees. And that's pretty simple. So remember when I said to convert? That's because pi is 180 degrees. And then on the flip side, this is either 0 or 2 pi, depending on how you look at it. It's 0 if you're starting here. It's 2 pi if you've gone around all the way. Which makes sense because no pi is 0 degrees, and then 180 is 360, which is a whole circle. Yeah. Anyways, so 1, 1, 1, 2, 3, 5, 7, 5, 4, so 7 pi over 6, 5 pi over 4, and then 4 pi over 3. Holy shit, that is a bad pi. I don't really give a crap. You understand what's happening. Alright, and then 3/2 pi. Up there is 1/2 pi. Like, it's really easy. This is the easiest part, because you're just doing it in fourths. And if that's pi, so then you have to have 1/2 pi. So 1/2 pi, pi, 3/2 pi, 2 pi. It's actually really easy. Yeah, so that's 2 degrees. 3 pi halves. Anyways, so 1, 1, 1, 2, 3, 5, 7, 5, 4, 5, 7, 11. So just think 5, 7, 11s. Close it out. So 5 pi over 3, 7 pi over 4, and then 11 pi over 6. And then bam. Now you got all your radians. Yeah, it's really easy. It'll take like 30 minutes. Just literally just keep writing them down. And again, denominators, they're the exact same. While the values will change, the reference is either going to be a 30, 60, or 45. And you can tell that by the denominator. If it's a 30 degree, 30 degree is the smallest. 30 degree is from here to here, or here, literally, you can point any of these. That's the smallest, divided by 6, 45, this one, divided by 4, and then the largest, minus, like, 90 degrees, is 60, which is divided by 3. It's the exact same. The denominator does not change for any of these. The denominator will stay the same, no matter, like, yes, you know what I'm saying. I'm yapping right now. Alright, now for the, it's not hard at all, actually. It's the same thing. The coordinates don't change. That's when the denominator really comes into play, because the coordinates do not change. The only part you need to know is where they are on the field, because then you got to look at your sign, SIGN. Is it negative or is it positive? So, oh boy, I got to remember this. I haven't used the coordinates in a while. If I'm not mistaken, this is going to be... Oh, actually, also, you can kind of guesstimate it. So, 45s are the easiest, because it's always root 2 over 2 for both of them. That doesn't change. Root 2 over 2. And you won't really need to know this, but so that means tan is y over x. Or tan is y over x, or sine over cosine. Sine represents your y, cosine represents your x. You'll learn that. You'll use it a lot in pre-calc. So it's y over x. You can plug that in, and you get, I think it's 2, let's see. I don't care about doing that. Well, I'll do it in a second. Give me a second. Anyways. God, it's going to be really hard to follow. I'm sorry about that, but I'm, like, kind of... Well, I have ADHD, so it's bird brain. I'm bouncing around here. But tans, honestly, doesn't matter that much. Like, she might ask you that for the quiz, but after that, you really don't need to know them off the top of your head. Because you'll never actually use it, really. So really just ignore it. If she asks you, it's really easy, because you don't even need to know off the top of your head. You can just solve for it. Y over x. Just, like, as long as you know your coordinates, you can find tan always. Just do y over x and then simplify it. Anyways, so 45s are always easy, because it's that radical 2 over 2, radical 2 over 2. They're always the exact same. The only thing that changes is that, like, okay, so now your x is negative, because think about it, coordinate field. Now we're on the negative side, so now it's negative root 2 over 2, root 2 over 2. Bam. And then this pattern follows. Oh, now we're in negative y as well. So now we are negative root 2 over 2, negative root 2 over 2. Oh, x is positive now. So now we're root 2 over 2, negative root 2 over 2. Bam. Those are all your coordinates for 45s, which is really easy because, oh, look, it's divided by 4, then you know it's going to be like that. Once you see it's divided by 4, all you got to do is figure out where on the unit circle it is, and then from there you can be like, oh, it's negative here, negative there. And a really good trick to do this is, oh, that's a little big, or a little small, I mean. Alright, so the acronym we use is all students, oh, come on, take calculus. What this means, in this quadrant, all are positive. In this quadrant, sine is positive, because s is sine. In this quadrant, tan is positive, because if you think about it, since they're both negative, negative divided by negative is a positive. And then down here, cosine is positive, because we're back on the positive x-axis. So that's a great way to know whether what's going to be positive, what's going to be negative. And that's the hard part about coordinates, because the coordinates are always the same. No matter where you are, no matter what angle it is, if it's one of the angles on the unit circle, it's going to have the same coordinates as anywhere else. It's just, is it negative or is it positive? All right. Now for the slightly more difficult one. I mean slightly, like, it's very slight. So this one, this one is the one you can honestly eyeball. Like, if you look at this, right? You'd say x is farther than your y. There's more x than there is y. Okay? So then, in the 30s and the 60s, you only have two numbers you'll be using. 1/2 and root 3 over 2. Root 3 over 2 is larger than 1/2, by the way. So in this scenario, your x is root 3 over 2, and y is 1/2. For your 60-degree angle, swaps. Your x is 1/2, because you can see, like draw down, now x is shorter, but y is taller. So 1/2 root 3 over 2. Bam. And you know what? It's the exact same for every single one, minus sign. Oh, x is negative now, so now it's negative 1/2 root 3 over 2. Oh, negative root 3 over 2, 1/2. Oh my god, exact same thing, but now they're both negative. So negative root 3 over 2, negative 1/2, negative 1/2, negative root 3 over 2. Oh, x is positive again. Woo! So now we're 1/2. Negative root 3 over 2. Root 3. Oh, fuck. Christ. 3 over 2. Negative 1/2. Bam! You learned all your coordinates. That's the whole unit circle. That's it. It's literally the exact same thing. There's two things you need to know. You need to know your coefficients. So you learn the coefficients. Once you learn the coefficients, the ASTC, all students take calc. I mean, just memorize that. It's 4 words. Memorize that. That'll deal with your signs. Really, just learn your coefficients and learn the first 3 coordinates, and then from there you can just turn them into the rest of these by just using your knowledge of the coordinate plane. It's really easy. Yeah. And then so you get a number like, I don't know, a number that takes more than one circle around. Nothing to fear. You know all the you know all the coefficients, so you're just gonna find how many more it goes down. So like, say we get like, I don't know, 14 pi over 6. Well, we know one wraparound is going to be 2 pi over 6, so what's that? 12 pi? So it's just 2 pi over 6. Which doesn't, I don't know. It doesn't matter. The other thing is, you'll never need, I honestly, okay, that was just confusing for no reason. Sorry, I didn't bring that up. I realized that you'll never actually have to do that without a calculator, and that won't be on the quiz. If Cher asks you to do something like that, you just you have a calculator to do it. So don't just completely ignore that. It does not matter. But yeah, that's the unit circle. Oh, and then for these coordinates where it's like this, it's either 1 or 0. X is 1, y is 0, x is 0, y is 1, x is negative 1, negative 1, y is 0, and then 0, negative 1. That's it. And then for degrees, I'm not going to write it down because Miss Burns will ask you for degrees actually. But say you want to find degree, where's pi? Plug 180. So say it's a pi over 3, 180 over 3, 60, it's a 60 degree angle. Bam. Woo! It gets a little more annoying with the bigger numbers, but like, you can solve that. 11 times 180. Off the top of my head, I cannot tell you that, but I don't know. Like that's it. If you really need to know, then you'll figure it out. Most times they'll do that. They'll give you a calculator anyways, so it shouldn't even matter. That's the unit circle though. So yeah. All right, I'll give you steps. Step 1: learn all students take calc. It's the easiest thing to do. It's 4 words. I'm sure you got that. Step 2: learn your coefficients of pi. I can't spell coefficient off the top of my head. Coefficient. Something like that. So learn your coefficients of pi. 3: learn your coordinates. I'm going to do COR because it's too long. Coordinates of the first. Just learn the coordinates of first 3, because once you learn those 3, you can just translate that to any of the other ones. That's it. There's no. I mean, you could individually memorize all of them, but it's just easier to memorize 3 and then think about where they are in the graph and just change the negatives and positives. It takes nothing. That's it. Those are those three steps to greatness and power. If you have any questions, just text me. This video is like really not schizophrenic, really ADHD, but it's better than nothing, alright? And I could make another one if you really want me to, but I don't know, it'd probably be worse, to be honest. Yeah, just ask me any questions you have. Alright, I hope you have good luck and all that shit. Bye-bye.